Now let's have a look at conditions and looping. And the Java language has many of the familiar programming methods to check for a condition, including the if-else statement. And on the slide, we have some code that includes an if-else statement, and this allows you to evaluate an expression and perform different actions depending on if it's true or false. So in this example, we check to see if the value of our variable a is equal to the value of our variable b. And since our expression equals false, it will then print out false to the screen. The switch statement is used when you need to have certain blocks of code executed depending on the value of a variable. You tell the switch statement which variable you want to compare, and then you write case statements, which ends up being the start of the blocks of code to execute when the variable equals that targeted value. You do need to remember to place a break statement before the next case statement, otherwise your code will fall through and it'll end up running all the following code blocks until it finally does hit another break statement. So unless that's the behavior you want, you really need to make sure that you don't forget those break calls. You could use if-then-else statements instead of a switch statement, and this would be a better choice if you need to test specific expressions based on a range of values. If you're only testing if a variable equals a specific value, switch statements can be better for reliability of your code. Now in Java SE 7 or later, you can use string objects in your switch statements expressions. Now the code snippet on our slide here demonstrates using strings in our switch statement. The while loop performs a test and then continues if the expression evaluates to true. So the while statement evaluates our expression, which has to return a Boolean value, and if the expression does evaluate to true, our while statement will execute that statement in the while block. So the while loop shown on the slide, it iterates through an array using a counter. And so we end up with the output from this loop of having value of x is 10, 11, 12, 13, all the way to value of x 19. It's going to increase the value of x, since we have the x++ statement. So x becomes 20, it goes back up to the top of our while statement, checks to see if x is less than 20, it's not, so it breaks out of our loop. There's also a do while loop, where we actually have our tests after our expression has run at least once. And so the difference between do while and a while is that a do while evaluates the expression at the bottom of the loop instead of at the top. So the output from the example in our slide here would be value of x is 30. So we actually do our system.out.print line statement, then we increment our counter for x, and then we do our check to see while x is less than 20. So it's, even though it was equal to 30 to begin with, we're going to run those lines first and then do our check. The for statement provides a compact way to iterate over a range of values. It repeatedly loops until a particular condition is satisfied. So we have a counter that's initialized, and then we have it incremented for each step of the for loop. And when the condition statement evaluates to false, for example, when I is no longer less than 9 in this case, the loop will exit. And our sample output from this program would end up being I is 0, 1, 2, all the way up to I is 8. Then we check for our condition is I less than 9. If we've incremented it and I equals 9, then it's not less than 9, so it won't print out I is 9. And lastly, we'll have a look at arrays. And our class on the slide demonstrates how to define arrays in Java and iterate over the arrays using a for each loop. The first array is called names, and it creates a string array and initializes each element separately. Our second array, which is numbers, is simply an array of integers, and each array is iterated through using the Java for each construct. The enhanced for loop is used to make the for loop more compact and much easier to read, and it's used to access each successive value in a collection of values. So it's commonly used to iterate over an array or even a collections class, for example, an array or an array list. So in our case, since we have our two for statements, output would be name blue shirt, name red shirt, name black shirt for the first one, and then in our second for statement, we have numbers 100, number 200, number 300. Now, arrays are also objects by default, and all arrays support the methods of the class called object. And you can always obtain the size of an array by checking for the length field.